Dear viewers, today, we are going to talk about counter mode of block cipher mode of operation with implementation of AES Rijndael Cipher. First of all, counter mode, also known as CTR, is a simple counter-based block cipher implementation. Every time, a counter is combined with a nonce and is encrypted with the key and given as an input to X or with plain text block which results in cipher text block. The CTR mode is independent of feedback use and thus can be implemented in parallel. Secondly, in CTR, it uses sequence numbers called as the inputs. Usually a constant is used as the initial counter value. It is incremented for every iteration. Everything will be further explained later. The encryption and decryption process are as follow. For encryption, the block of cipher text is produced by encrypting the key in nonce and X or with the plain text block. While for the decryption, the block of plain text is produced by encrypting the key in nonce and X or with the cipher text block. This diagram here clearly shows how the encryption process flows. At the top is a nonce combined with a counter. The nonce is a random value alike the initialization vector, IV, that is used in other block cipher mode of operation. The counter is incremented in every iteration by a constant value. As for the key, it is a secret key pass between the sender and receiver. The nonce, counter and key will then be converted into binary form to be encrypted using block cipher. A bigger view of it will be like this. The original plaintext will be broken down into blocks of plaintext blocks. Every plaintext block contains 128 bits. It then X or with the output from the AES encryption which contain also 128 bits. After that, it produces the cipher text blocks. Every block contains also 128 bits. All the cipher text blocks will then be combined and results the whole cipher text. If the plaintext block size is equal to the encryption output block size, then the two blocks will be XOR together and produce the block of cipher text. In the other case, if the plaintext block size is less than the encryption output block size, then only the size of the plaintext block of the output will be taken and XOR with the plaintext and produce a shorter cipher text block. Here is a demonstration of the encryption process. All blocks are simplified into 4 bits for better understanding. First, the nonce, 11, and counter, 00, is combined and encrypted with the key, 1110, using AES encryption. The encryption produces a 4-bit block contains 0110. It then X or with the plaintext block 1010. And finally produce the first cipher text block containing 1100. To the second iteration, the nonce remains the same, but the counter is increased by 1, producing a 1101. It then encrypted with the key 1110 and produce 1101. The output block is now X or with the plaintext block 2, 1010 and producing the second cipher text block containing 0111. As shown in the diagrams, although the same nonce, key and plaintext is used, but with different counter, the cipher text output will be different. The previous processes are continuing until the last plaintext block is encrypted. One thing special about counter mode is that all the iterations are independent, not relying on the feedback or output from the previous iteration. That's why the encryption process can be ran in parallel. Here comes the decryption process. Almost same with the encryption process. The cipher text is broken down into cipher text blocks. It then X or with the output from the AES encryption and producing the plain text block. Lastly, the plain text block is combined and producing the whole original plain text. Here comes the demonstration. The nonce, 11, is combined with the counter, 00, and is encrypted with the key, 1110 using the AES block cipher. It then produces the output of 0110. The output is now XOR with the first cipher text block, 1100. And finally the first plaintext block containing 1010 is produced. Same goes to the second iteration. The nonces remain the same, and the counter increases by 1. It then encrypts with the same key producing the output of 1101. The output then X or with the second cipher text block, 0111 and finally produce the second plaintext block containing 1010. This decryption process will be carried out until the last cipher text block is decrypted. And that's all for this video. Thank you for watching.